Hi everybody, welcome to another video. This video is going to be about amines, next section on our organic chemistry journey. So, amines are ammonia with a carbon chain attached instead of a hydrogen. So they are also known as an alkyl derivative of ammonia. Alright, so an alkyl derivative of ammonia with some carbon attached. Cool. They can be classified as primary, secondary or tertiary. But unlike haloalkanes and alcohols and other things that you come across so far, the classification depends on the number of carbons attached to the nitrogen atoms. So, primary have one carbon attached to the NH. So, here we go. Carbon NH2. So, one carbon attached to the nitrogen. Secondary have one hydrogen and two carbons attached. Alright. Tertiary have a nitrogen with a carbon, and a carbon. Now always remembering that nitrogen has that extra lone pair of electrons sitting on top of it. Okay? Right. So, just reminding you that these come across. Now of course, I say this in the next slide, but I'll say it again now. This year, you need to focus on these ones. You need to know that these things exist, but you will not be asked to name them. Possibly might be asked to figure out that they react the same way as ammonia and amines do. But we focus on the primary. So, back to here. So, nomenclature. Amines can be named in two ways. So you can think about these as being substituents of an alkane. So you have the alkane, which is the methane, and then you have a substituent, so beforehand, so aminomethane, okay? Or an alkyl derivative of ammonia. So you've got amine at the end, and then the whatever the group is at the front, the carbon chain at the front, so methylamine. Same thing, two different ways of naming it. This year you only need to know how to name primary amines. However, there are examples of secondary and tertiary amines on page 130 in your workbook. So if you want to go and have a look and see what they look like, then that's where the place to go. Making and physical properties. So to make an amine, we make it from haloalkanes with ammonia in alcoholic solution. If you can't remember how to do that, again, go back and have a look at the previous video on haloalkanes, or check out in your workbook the section on haloalkane, which I can't remember off the top of my head. There it is. Page 123 will tell you more about how to make amines from haloalkanes. Things to remember: that amines have an unpleasant fishy smell. Smaller amines up to 5 carbons are soluble in water, but larger ones are insoluble, as the size of the non-polar hydrocarbon chain cancels out effect of the polar amino functional group. So the longer the chain is, the more that carbon chain takes over the polarity kind of effect. So yeah, the fishy smell. Fishy smell though is not a complete distinguishing test on its own. So if you're asked to distinguish between things and one of them is an amine, don't say, smell them all and the one that smells like fish is amine, because that's not going to get you very far. Okay? Alright, so here we go. Reactions. I've already said it once and I'll say it again and again and again. Amines this year are the only basic group that you will come across in organic chemistry. So it is like ammonia itself. The water-soluble ones form basic solutions. They react with the water, proton transfer, to form OH- ions. This means any aqueous solutions of amines turn litmus blue, and that is the prime example of how to distinguish between amines and pretty much anything else. You know, the prime question of Mrs. Hay accidentally lost all the labels on all her bottles. She has all these clear colourless liquids and doesn't know which one's which. Yep, so to be able to figure out an amine, stick it in litmus. So here is the equation for you. Alright, so I'm actually just going to take that back one step and doodle. Poodle. So this is exactly the same as last year, and I'm hoping you can remember this. This one should actually be an equilibrium arrow as well, by the way. So this is just like NH3 plus H2O goes to make equilibrium arrow. Goes to make NH4 plus NOH minus aqueous. Okay, you should hopefully remember that from last year, that this is an equilibrium reaction. Generally speaking, the equilibrium lies to the left, and same thing with this organic compounds, so the amines. The equilibrium will lie to the left, but that doesn't mean that you can't discount this. This is there, and it is there in enough proportions that is going to make a basic effect. Yep, so this is accepting a proton, and this is donating a proton. So this being a proton acceptor, it is the base. This being a proton donor, it is the acid. Okay, this being one proton different from this is the pair, the conjugate pair. So this is the conjugate base, and this is the conjugate acid. This is the conjugate acid, and this being one H plus difference is the conjugate base. Just keep that in mind for when we do equilibrium. It'll make it a hell of a lot easier. So here we go. They also react with acids to form salts. So in the similar way that we would have ammonia, so NH3 plus HCl going to NH4Cl, ammonium chloride. Right, we have aminomethane plus hydrochloric acid going to methyl ammonium chloride, Okay? Cool. So here's some questions for you. Write the structural formula for a 5-carbon primary amine, secondary amine, tertiary amine. How would you confirm that a colourless liquid was an amine other than its smell? If you rerun the video about 2 minutes, I will tell you the answer to that one. And then write equations for the following reactions and naming the organic products for A and B. Aminomethane with water and aminomethane with hydrochloric acid. And 1-aminopropane with copper 2+. Ooh, that one's a good question. Think about what reaction occurs between ammonia and copper 2+. This one you might need to think back to making the pretty colours back in year 12 and doing the pretty colours stuff where you mix it all together and made some precipitates and didn't make precipitates. Cool, so if you answer those questions, come and see me in class. That's all for this video. I will see you next with aldehydes and ketones.